Okay, hello everyone. I'm making a video on machine learning, binary classification. So in this video, I'm going to show you how you can build a machine learning binary classification using logistic regression, and I'll also show you how you can deploy your machine learning model into a simple web application using Flask. So, but before we start going through the codes, let's just discuss briefly about a binary classification, and then before we go into the code, a binary classification. So we're just using a logistic regression. So what do you understand by binary classification? Binary classification is a machine learning task that is tasked with the goal of classifying data into two distinct classes. So it's a supervised machine learning. Uh, so into two distinct classes. So it can be. So you're going to build a model that will be able to detect whether something is right or wrong, or whether something is fraudulent or not fraudulent. So it's always benefit is always between 0 and 1. 0 and 1. Let me show you an example of what I mean from the data I have here on health. So heart disease. So this is the target of the model, building a model to detect whether an individual has a heart disease or not. So it is classified as between 0 and 1. That's why it is called binary classification. So we have just two classes, 0 and 1. So we're going to build a model that is going to determine if an individual has a heart disease or not. So this is kind of like a real life data. Okay, so we're going to train the model using the following inputs: age, sex, chest pain, resting BP, cholesterol, fasting BS, resting ECG, maximum heart rate, exercise angina, old peak, and slope, and ST slope. So these are some of the input data we're going to use to build a model, to train the model enough for you to have to be able to classify whether the individual has a heart disease or not. Okay, so this is what we're going to do in this video. So we're going to use logistic regression. Logistic regression is a classification algorithm. Is not a regression algorithm, and it predicts the probability that a given input belongs into two classes. So this is how it works. It computes the weighted sum of the inputs. This input we have here, is going to compute them, and also the output then is then passed through a segment function that converts it into a probability in the range of 0 and 1. We know what a segment function is. You can read more about segment function. Okay, so and the threshold is always defined in the model. Okay, so now we have a basic idea of how it is. Let us go into our codes. So these are some of the libraries that will be needed to build a machine learning binary classification model. Okay, so we're going to import this from sklearn linear model logistic regression. We need the pandas, we need seaborns for visualization, and also need a numpy because machine learning works with numpy array. So we're going to convert our data into a numpy array, which we will see as we progress. So we're going to evaluate our model using a matrix, confusion matrix, which I'm going to show you how it is done. So the first thing we're going to do is we bring in our heart data. we're going to bring it into the project using pandas. So we're going to bring it in pandas. So we do some inspection. We're going to inspect the data to see if they are missing data. So these are the data has been brought in: the age, sex, chest pain, and likes. And this is our target, heart disease. Okay. So after doing that, we check if they are missing data. So using this code is null sum. So it's going, what this code is going to do is going to bring out the sum of missing data that we have if they are missing data. So when you run it, you see that age, no missing data in age, no missing data in sex. So our data looks pretty okay in terms of missing data. So we're also going to check if there are duplicates. Yeah, so it shows there's no duplicates in the data. Okay, so now it is time for us to identify our dependent variables and also the independent variables. So the dependent variable here, which is our target, is y and is heart disease. So we brought it out of the data we have here. So it was brought out. So when you run this now, what you see is our value for y. So this is our value for y, and so for y, and when you run this, we see it has dropped the heart disease, which is our dependent variable. So now we'll be able to differentiate differentiate the independent variables and dependent variables from our data. So we now have our x variable and also have our y variables. Okay, so now just for us to have more insight on the data and what we are working on, we decided to choose select one feature. Okay, let's say we're using old pec. Okay, using old pec. So for us to have an insight on what we're doing, we want to be sure that our classification is what it is actually binary. So now we're checking if we have values that are greater than 0 and 1. So everything is less than, everything here is less, all data we have is less than 2. So let's check again if it is less than 1. We have data that are less than 1. Yeah, so we have data for 0. We have this one is less than 1, so definitely 0. This one is 1, which means it's false. So this one is just for us to check to see if our data is actually, if our dependent variable is actually binary. So from what we have here, we can see that it is binary. So now we're using one feature just to check. We're using old pec. Okay, so we're converting our independent variable into numpy array. So when we bring it out, so this is a numpy array which we have here. It also yeah. So this is our numpy array. But when you look at it here, you see that because we said our y should be less than 1, so it's not really fully capturing all the data because it has eliminated our values of class 1 values and then puts everything to be 0. So we have to return it back in order to have a full capture of our y data. Okay, so we run it back. So right now it's gonna captures 1, 0, 1, so it fully captures our data. Okay, so now we have that. So we're trying to have a picture of what we have so far on a scattered plot. So we're plotting our old peg against our y value, and a y tick of 0 and 1. So this helps us to see which of the values falls between 0 and 1 using old peg. So this is just part of the inspection. We're just trying to for us to understand our data much better. Okay, so we run this data. So what we have here, we have old peg values extending to negative, just as we have here old peg values. Yeah, we have data running down to negative. So it's like plotting this against this. Okay. So that's it. Now we have that. So because we are using just one value, just one input feature, we need to convert this our value of x1 value into a 2D for it to be used for model. So we're converting it into a numpy array on a 2D numpy array. Okay, so after that we split the data. We split our input values and also split the output values, the expected output values at 80 to 20% ratio. Okay, so we run the model, we fit into the model. So run this, also run that to the model. So we now fit it into our logistic regression model. Okay, so when we do this, we have a score of 0.68. So the model still requires more data, because the result we're getting here is just based on one input value, that is one old input value of this old peg value. So we still need to input more of the values for us to have a better results. Okay, so that's what we're going to do next. So here we plotted our results, and that's what we have. So the probability here is correct, I mean, because it's between 0 and 1, yeah, of class 1. So probability of class 1, and what we have here is 0 and 1. So what we've done here, we plotted the x test, the y test. We also plotted the mean and max value, where it has been reshaped into a 2D. Okay, then we carried out a probabilistic model. So this one gives us the probability, the class 1 probability of what we've done so far. So what we've done, the result of what we got, is within the range of probability of 0 and 1. Okay, so now we can't trust this model because it has just one feature, which is old peg. So we're going to we selected all the features we have, okay, for us to have a full model. So what we did here, we made a copy of our x, of the input values, our x value. Okay, a copy of this, with a copy of our x values. Okay, so now because machine learning models often requires a numeric value, and what we have in our data, we have two data types. We have categorical data, and we also have numeric data. Okay, so we need to capture both the numeric data and the categorical data in our model. So first thing we did was to differentiate, to identify the categorical columns, and also to identify the numeric columns. Okay, so after doing that, we we normalize our data, the numeric data. Okay, we normalize it using standard scalar. So the reason why we're normalizing our data is just to rescale the data, so that they all have all the data will all have the same scale. Otherwise, larger data will take dominance over larger figures will take dominance over lower figures in the machine learning model. So that is why the numeric columns were normalized. Okay, were normalized. So when you look at the data we have here, numeric columns, they are basically all close within a close range. We don't have any data that is far higher than other. Otherwise, the larger figures will take precedence, will dominate the data. Okay, so we put everything. We're trying to use a pipeline this time. So we try to use a pipeline. Now, what we did was to transform our data, prepare them so that we can put them into the pipeline. Okay, so our normalized numeric columns were brought in, and also because machine learning uses understands numeric data, so we did a one-hot encoder just to convert our categorical data into numeric data. So when you check the data we have again, we see that these data needs to be categorized. Okay, needs to be categorized. It has option of female and male, that is for the sex, and also the chest also that needs to be categorized also has figures of ASY. So all this data needs to be converted one hot encoded in order to be recognized by the machine, by the model. Okay, so that's what we've done here, one hot encoding. So this preprocessor was now brought into the pipeline along with the logistic regression model. Okay, so doing this, then we will now split our data. After splitting the data, everything was now put in the pipeline. So when you run this, so everything is now put in the pipeline. So what we have in the pipeline is normalized numeric data and the one hot encoded categorical data, okay, all into the logistic regression model. So the LG pipeline was now used to evaluate our model. Okay, so we've run the model, we've trained it, we trained the model. Okay, LG.fit. Then we're trying to get a score of a model. The score for model is 85%, which is not too bad, although it can be improved, but currently it is 85%. Okay, so now what we're trying to do now is to evaluate our model. Okay, I want to evaluate our model. So we have our test data. Okay, our test data, which was used to run, which we're using to run a prediction. So we want to predict y values using our text data. Okay, based on the logistic regression model that has already been built. Okay, that is this one here, that's already been built. Okay, so now these are prediction. Okay, our predictions are between 0 and 1, just as we discussed earlier. Alright, so let's now check how good our model is in the prediction. Okay, how good our model is in the prediction. So we're using confusion metrics. Okay, we brought in our y text, also brought in our predicted values of y, which is this. Okay, into the model, and we displayed it in a plot. So from run this confusion metrics, we see that out of all the data we have, Okay, 89 of the data was predicted to be a true positive. That is true positive. Why 9 is false? So we got 9, we got 89, and we're missing 9, which is not too bad. It's not too bad out of the model, although it can be improved. While 86, 68 was predicted to be 0, while 18 is false. Okay, 18 is false. So what this is saying is this: based on the data we have, 0 and 1. 0 means that the data we have shows that the person has doesn't have a heart disease, while 1 means that from data we have, the person data we have shows that the person being checked has a heart disease. So 89 have heart disease, while 68 does not have heart disease. So this is what we have based on the data that we have, and the model is 85% accurate, although it can be improved. So now we're trying to transfer our data into a web application using Flask. Okay, so I'm going to pause the video here, and we'll continue from here in the next video. Okay.